Today's lesson is called Angles and Parallel Lines Day 4. Early in the year, we learned how to solve an equation. So I'd like you to show me what you know by solving the equation below. At this time, pause the video, try to solve the equation, then resume the video to go over the answer. Okay, so for 7n minus 2 equals 5n plus 6, let's go through our checklist. First thing we want to look for is distributive property. I do not see it. Next thing I look for is like terms. So I look at the expression on the left-hand side. Are there any like terms to combine? There aren't. I look at the right-hand side and I see if there are any like terms to combine, and there aren't. So then I can move to variables on both sides. I do see variables on both sides. And since it's even in size, 2 terms on the left, 2 terms on the right, I can move the 7n or the 5n. I'm going to choose the 5n since it's the smaller number, and then I can avoid some negative number usage. So if I see a positive 5n in front of me, I want to subtract 5n. Whatever I do to one side, I need to do to the other. So 7n take away 5n is 2n minus 2. On the other side, the n's have canceled, and you have 6. From here, it should be a 2-step equation. So we have 2n minus 2 equals 6. We want to get rid of the addition or subtraction next. We have subtraction of 2, so we're going to do the opposite or inverse operation of adding 2 to both sides. So we get 2n, the negative 2 and positive 2 cancel, and on the other side we get 8. I don't want 2n, I want just 1n. So 2n means multiplication. We want to do the inverse operation, which is to divide. You always divide by the coefficient of the variable. So you should be dividing both sides by 2. So here you get n equals 4. So that's a quick review of solving equations. Now we're going to go down and look at something else we've been doing recently and review. It says we recently learned about the special angles created when parallel lines are cut by a transversal. Again, I'd like you to show me what you know by finding the measures of the missing angles below. So again, pause the video and then resume the video when you're ready to check your answers. So it says the measure of angle 1 is 45. It's going to mark this one as 45. And then we know that we learned special angle relationships when parallel lines are cut by a transversal. We have vertical angles such as 1 and 3, 6 and 8. That means they share a common point but no common side, and they are equal or congruent. We have alternate interior angles like 4 and 7 and 3 and 8 that are congruent. We have corresponding angles like 1 and 8, 2 and 7, 4 and 5, 3 and 6 that are congruent. We also have alternate exterior angles like 1 and 6 and 2 and 5 that are congruent. And if you are not one of the special angle relationships, then you are supplementary, which remember means that you add up to 180. So when I'm looking at this picture, when I see angle 1 is 45, I said, okay, I know angle 3 is also 45 degrees because they are vertical angles and therefore would be the same. I also know that 8 is 45 degrees because 1 and 8 are corresponding angles and therefore congruent. And I also know that 6 is 45 degrees because angle 1 and 6 are alternate exterior angles and therefore congruent. When it comes to finding the other angles, for example, let's look at angle 2. You can see angle 1 is acute, a small angle less than 90, and angle 2 is obtuse. It's larger than 90. So just by common sense, these two angles should never be the same size. That tells you that we have to figure out the supplement to this one. So angle 1 and angle 2 in the picture are equal to 180 degrees. Because remember, if you're not one of the special angle relationships, you add up to 180, which is called being supplementary. So I want to do 180, take away 45, in order to see what my other angles are going to be. So I get 135. So now I know angle 2 is 135 degrees. And now similarly as we did with 45, I can reason my way through the rest. Angle 2 should be the same as angle 4 because they are vertical angles and therefore congruent. 2 should be the same as 7. So 7 is 135 degrees because 2 and 7 are corresponding angles and are congruent. And 2 should also be the same as 5 because they're alternate exterior angles and therefore congruent. So now why did we review these two things? Let's go to the next page. These concepts, although taught separately and can operate separately with their own kind of problem, can also work together. So these concepts can also rely on each other. So you're going to see a picture here of parallel lines cut by a transversal, but instead of degrees as your labels, you're going to see expressions as your labels, 3n plus 16 and 5n plus 4. So when this happens, you want to go through this 4-step process. Most of the time 3-step, but I do want to show you the 4th step that could appear in order to answer questions. So we're going to put the two pieces together. The first thing we're going to do is use our knowledge of what we just did with our angle relationships. So we're going to look at the picture, and I'm going to mark this in blue here. This is my first angle, and this is my second angle. And if I look at this picture, I'm trying to see if there's any special angle relationship going on. And there is. 3n plus 16 is inside on the right side of the transversal. 5n plus 4 is inside on the left side of the transversal. So that means that these angles are alternate interior angles from our special angle relationships. So once we determine the actual pair, we need to make a decision about how we're going to write the equation in step 2. And the first decision has to be what's going on based on the types of angles that they are. As you remember, I said previously, there's only 2 options in this picture. The angles are either a special angle relationship and they are congruent, or they're not. One is acute and one is obtuse, and therefore they are supplementary, which means they add up to 180. So in our situation, are the angles congruent or supplementary? Our angles are alternate interior angles, which is one of the special relationships. So that means they are congruent. So when it comes time to writing the equation, we have to write the equation showing that those two things are congruent. So let's think about what congruent means. Congruent means same, but also equal. Those are all words that could mean the same thing as congruent. So that means the angle that is marked with 3n plus 16 should be equal to the angle that was marked with 5n plus 4, because alternate interior angles are equal. Now, side note, our angles are not supplementary, but supplementary, remember, means add up to 180. And if something does add up to 180, you literally add them up and equal them to 180. So it would be something like 3n plus 16 plus 5n plus 4 equals 180. That would be what it is if it's supplementary. But again, ours is not supplementary. We have a special angle relationship, therefore ours is equal. So I want to put an equal sign between the 2 angle measurements. 3n plus 16 is one angle. That should be equal to the other angle, which is 5n plus 4. So now you can see why we reviewed equations, because once we use the angle relationship to set it up, we can now solve it. So we've got 3n plus 16 equals 5n plus 4. I do not have distributive property. I don't have like terms on the left or the right, so we move right into variables on both sides. I'm going to get rid of positive 3n by subtracting 3n from both sides. So 16 equals 2n plus 4. I then can get rid of the addition of 4 by subtracting 4 from both sides, keeping my equation in balance. So I get 12 equals 2n. The 4's cancel. And then I want to divide by the coefficient of the variable, which is 2. So I see that 6 is equal to n. So now I know the value of n. Now, a lot of questions will just have you stop there. Use the information to find the variable itself. But sometimes we get something like step 4. Use the value of the variable to find the measure of the angle. Now, these angles are the same. So it doesn't matter if you use 3n plus 16 or you use 5n plus 4. I'm going to use 5n plus 4. So that's the current label for my angle. However, I already found out n was 6. So we're going to use this and we are going to substitute in. So 5 instead of n, we're going to put 6 because we know n equals 6. And then we follow our order of operations. 5 times 6 is 30. 30 plus 4 is 34. So the measure of the angles are actually 34 degrees. So what I'd like you to do now is do the try it on your own problems. Now that those have been modeled, number 1, find the value of x. And number 2, you're not fully solving. You're going to look at the picture and answer which equation will help you find the correct value of x. So at this time, pause the video, and when you're ready to go over answers, you can resume. Okay, let's look at number 1. First step is we want to look at the angles that are marked and think about what angle relationship they have. Looking at this picture, I see a set of corresponding angles. Corresponding angles are one of our special relationships. So that means in this case, they are congruent. Because think back above, we circled either congruent or supplementary once we decided what kind of angles they were. They're both obtuse, they're going to be the same size. So that means these expressions that you see should be set equal to each other. The angle that is 2x minus 60 should be the same size, congruent, or equal to the angle that is marked x. Now again, no distributive property. I don't see any like terms to combine on the left or the right, so we go right into variables on both sides. This equation is uneven in size. We have 2 terms on the left and only 1 term on the right. So we want to get rid of the variable on the side with more stuff. So that would be the 2x. It's currently positive, so we are going to subtract it. Whatever we do to one side, we must do to the other. So we get negative 60 equals x minus 2x would be negative 1x or just negative x. To get x alone then, remember there's really a negative 1 here, we would have to divide both sides by negative 1 and see that 60 is equal to x. That's our answer. When you go to number 2, which equation will help you find the correct value of x? Let's look at the angles that are marked. I see this angle, which is an obtuse angle. I see this angle, which is an acute angle. It's not vertical angles. They aren't corresponding. They aren't alternate interior or exterior. They are none of our special angle relationships. And again, one looks bigger than 90, one looks smaller than 90, so they can't be the same size. So remember the 2 options are either they're equal, like in the first equation, or they add up to 180, like in the second equation. So we would see here that in this case, it's not a special pair. So that means they are supplementary. Which means, again, remember, they add up to 180. So I want to circle this equation. I want to take the 2x plus 40 and the 3x minus 85 and add them together to have them be equal to 180. Now, just quickly together, obviously different steps if this is the case. I see no distributive property, but for the first time, I see like terms. I would take 2x and 3x and make it 5x. I would take 40 and minus 85 and make it minus 45 when I combine them to get 180. And then you can see from there, you would add 45, divide by 5, you'd find your x value that way. All right, and that concludes our lesson on angles and parallel lines, day 4.